Alright, so we're going to start part 3 with a big old problem. This is our second problem where we need to find the degree, the end behavior of the zeros, the multiplicity of each zero, the x-intercepts, the y-intercept, and plot extra points, and we'll see if we can squeeze it all on this page. If not, I'll erase and fit it in there. So first of all, the degree. This is not our problem, y'all. We did this on the last one. Let's try this again. There it is. Okay, so first of all, the degree. Notice this is in factored form. Okay, so I've got an x squared here, which is going to give us 2, and an x squared here, which is going to give us 2. If we multiply this x squared times this x squared, that would give us 4. So this guy is a degree 4. What does that mean? A lot. It means we're going to have 4 zeros. They might not all be x-intercepts, but we're going to have 4 zeros. It has an impact on the end behavior. Let's talk about end behavior. The left, what's it doing? The right, what's it doing? Well, since it's a degree 4, we're talking about an even value. The leading coefficient's a positive 1 right here, so positive. Even and positive mean the left is pointing up and the right is also pointing upward. The zeros, we're supposed to set each factor separately equal to 0. Excuse me, please. All right, so over here I got 0 equals x squared minus 5x plus 6. And 0 equals x squared minus 5x plus 7. Now this looks familiar to me. Didn't this same problem show up earlier to find zeros? I need to this will factor. So 0 equals x minus 3 times x minus 2. That gives me x equals 3 is a 0 and x equals 2 is a 0. This dude does not factor, so I have to use the quadratic formula. So x equals be negative b, so negative of a negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 7 all over tiny 2a, and that equals 5 plus or minus the square root of 25 minus 28. I can't even read my writing, it's so small, all over 2. That's 5 plus or minus the square root of negative 3 over 2, which gives me 5 plus or minus I square root of 3 over 2. Now, I know that was a little fast, but I am pretty sure there's a problem in this review that asks you to find zeros of this very polynomial. So go back and look at that one. I don't know what number it is, but go back and look at it. Okay. Now, we need to discuss x-intercepts. Okay. I always like to change my color when I get to x-intercepts. X-intercepts. Let's sneak it right over here. I've got one at 3, 0. I've got one at 2, 0. I do not have any right here. Can't have imaginary x-intercepts. Now, y'all, if that I was missing, those could still be x-intercepts. If you can type it in your calculator and come up with a decimal, it's an x-intercept. You cannot type imaginary numbers in your calculator, okay? They're not real numbers. You can't plot them. There's no way to find them on an xy axis. So these two guys are our only two x-intercepts. In green, let's find our y-intercept. Let's see if I can sneak it over here and get my whole graph on this page. So the y-intercept, you plug 0 into the original function. So I have y equals, this is going to be 0 squared minus 5 times 0 plus 6 times 0 squared minus 5 times 0 plus 7. That's going to give me y equals 6 times 7, which is 42. So the point 0, 42 is my y-intercept. Okay? Oh, I did not discuss the multiplicity of each zero. So multiplicity, this 3 only showed up one time, this 2 only showed up one time, so that means at x equals 3, 0, the graph crosses over. Remember, 1 being an odd number, and odd multiplicities cross over the x-axis rather than just touching and going back the other way. Okay, so now we need to do a t-table. So I'm going to try to squeeze a t-table way over here, and then maybe that'll leave our room for our graph on the left. Okay, if you would like a cleaner version of this, please look at the handwritten key. And this is more about the verbal and the explanation of how I came up with what I've got. And so, you know, I know this can be hard to read, but look at the handwritten key. I try to do that a little neater, and you're not writing on a squirrely screen, which I'm learning. Okay, so I've got to, let's put our points that we already have. Like we have 2, 0, and 3, 0 from our x-intercepts, and 0, 42 from our y-intercept. So I want to put them in order. 0, 42 actually comes before, and I say order of x values, and then 2, 0, and 3, 0. Notice I'm leaving the space in between because I got to pick some values. If it helps, let's come over here and do our xy axis, because some people need to see this geometrically rather than just a list of values over here. So I'm going to do 0, 1, 2, 3, 4. Always label your scale. You do not have to label every point, but you got to label some of them so I know what your scale is. Y scale I don't want to do until this fancy t-table is done. Okay, so I already have some points. I have 0, 42. I'm not going to put that on there yet, okay, because I don't have a Y scale. I do have 2, 0, and I have 3, 0. There's my points right there. So remember, the rule is between and beyond every x-intercept. We already have something on the left of 2, 0. I'd feel better if we had something else as well. So y'all, why don't we plug in, like, say, -1. Okay, +1 would have been fine too. I do have to plug in something between, well, I have it. I don't know. Again, that would be 3 points to the left of 2, which may be overkill, but it also makes for a good looking graph, so it doesn't hurt to take the time to do that. I do have to pick something between 2 and 3. As not fun as that is, 2.5 is the winner, and I have to pick something on the other side of 3, and since the only value I have listed is 4, that's going to be what we plug it in. Where am I plugging that in? Into that original polynomial. So that's going to be y equals, here I go, tiny writing. That's going to be -1 squared minus 5 times -1 plus 6 times -1 squared minus 5 times -1 plus 7. It's worth taking the time to get this right, folks. So -1 squared is 1, minus 5 times -1 is plus 5, plus 6. And then my right-hand factor, -1 squared is 1, minus 5 times -1 is plus 5, plus 7. Okay, 1 plus 5 is 6 plus 6 is 12. 1 plus 5 is 6 plus 7 is 13. And then 12 times 13 is 156. And so I have the point -1, 156. Now what I want to do is the same evaluation, simplification for +1, 2.5, and 4. So here I go with +1. When I put in +1, I get 6 as my answer. When I plug in 2.5, I get -0.1875 is my answer. And then finally I'm going to plug in 4 and see what I get. 6 is what I get when I plug in 4. So check these. I will check them again as well. And we need to plot these points after we figure out what our Y scale needs to be. I'm noticing answers over here. I'm looking at my Y values. I've got 156, 42, 6, -0.1875, 0, 6. Now remember we said this one really wasn't all that required. It just kind of makes me feel better when I have on the graph. So I don't know if I'm going to focus on trying to get that high. We've got a 42. Maybe let's focus on getting more of that. And see, this is so small that I don't want to do a huge scale of like 100, 200, 300 stuff, because this will look like it's right on top of the x-axis, and it's not. It's close, but it's not on top of the x-axis. So how about we do, I don't know, let's just do 10, 20, 30, 40. So 10, 20, 30, 40, 50. Okay, so there's 10. -10, -20, -30, -40, -50. Now again, it leaves off this end guy right here. But if our graph still follows that pattern where it looks like at -1, it's going to be way up here at 156, well good, then we're fine, okay? So here we go. 0, 42. Now remember, this 10, 20, 30, there's 40, so 0, 42 is about right there. 1, 6. So 1, 6, a little over halfway between 0 and 10. 2, 0, we already had our x-intercepts graphed. 2.5, negative 0.1875. Do the best I can. Again, just below. Obviously, due to my scale, that's much bigger than negative 0.1875, but I don't want it to look like it's on top of the x-axis because it's not an x-intercept. 3, 0 I already have plotted, and 4, 6. So again, just a little above. Okay. Now remember, negative 1 is 156, so it's way up here at the top of my screen, which kind of matches what we have going on. Uh-oh. I got a little squirrely with my line. Let's try this again, okay? There we go. So now I've got to come down and meet this. Okay, it comes under and it comes up. Oh, it looks terrible. Alright, again, I'm a little out of control with this pen. I don't know how much writing you've done on top of a computer screen, but it's not as easy as you think it'd be. There we go. I'm cheating. Make it pretty again. Close enough. Sort of looks like a parabola, y'all. Now, keep in mind, this technique of doing all these steps in graphing, although it seems very thorough, but it's not perfect. What we cannot find is the minimum or the maximum. This parabola may dip way down here and then come back up and pick up that line. I've got it more looking like a regular parabola, but I don't know. You can see how it dips down lower than it does here? It may very well do that. It doesn't mean it's the lowest right there in the middle. Okay, so things you got to keep in mind. That's what you take calculus for. You learn how to do these perfect looking graphs in calculus. There's just a little bit of information we're missing right here. Oh no, we've got a third one of these things. That's okay. We've got this. Practice makes perfect. Alright, or at least improvement. Okay, so 0 equals x plus 5 times x squared plus 9 times x squared minus 16. What am I doing? I'm finding the zeros. Probably sooner than I have to. Let's back up. Let's find the degree. This is in factored form. Okay, so the degree again is not the highest exponent unless the polynomial is completely multiplied out, and this guy is not. So you have a first power from that, a second power from that one, and a second power from that one. We add those together. This is a degree 5. Next, we're supposed to find what's the end behavior doing. What's the right side doing? What's the left side doing? Well, with a degree 5, we're talking odd and a leading coefficient of a positive 1. Odd and positive, meaning the left side's going down and the right side's going up. That compares to your traditional x to the third graph. Now, finally, zeros, which I've already gotten started. It will factor a little more than the way I have it written now. X squared plus 9 will not factor more because it's a sum of squares, but x squared minus 16 factors into x plus 4 times x minus 4. And then I set each factor separately equal to 0. Alright, so x plus 5 equals 0 gives me negative 5. X squared plus 9 equals 0 gives me x squared equals negative 9. X is equal to plus or minus the square root of negative 9. And x is equal to plus or minus 3i. Okay, so remember the square root of a negative is imaginary. The square root of 9 is 3. X, it looks a whole lot like a 14. That's just x plus 4. So I subtract my 4. That gives me x is equal to negative 4. And then I add my 4, that gives me x is equal to positive 4. I need to list my x-intercepts. Remember, x-intercepts and zeros are the same calculation, except zeros are allowed to be imaginary numbers like we have. X-intercepts are not. So if I write negative 5, which is a real number in point form, that's negative 5, 0. This guy, hard to read, is negative 4, 0. And this guy over here is positive 4, 0. Now the question is, do I have all my zeros? Well, there's supposed to be 5 of them. That's 1, 2, 3, 4, 5, yes. And we only have 3 x-intercepts, and that's okay. Okay. Y-intercept. So y-intercept happens when you plug 0 in for x instead. So that's going to be y equals 0 plus 5 times 0 squared plus 9 times 0 squared minus 16. So y equals 5 times 9 minus 16. So y equals, let's calculate that. So I got negative 720. So 0, negative 720. Big old number. Is that okay? Yeah, it's fine. I don't want you to be alarmed by those things. They happen. Now, we need to discuss the multiplicity. Notice each one of these. This 0 of x equals negative 5 only showed up one time. We didn't get x equals negative 5 for several calculations, just once. So this multiplicity is 1. This multiplicity is 1. This multiplicity is 1. These two are also 1, okay? But now multiplicity really only matters for graphing purposes, although I do still want to know that multiplicity is 1 each right there. So that means right here the graph crosses, the graph crosses, the graph crosses. How do I know it crosses? Because an odd multiplicity means the graph crosses over the x-axis, whereas an even multiplicity, and not yet in this review have we had an even multiplicity, but an even multiplicity just touches the axis and goes back the other way. So this makes me think I need to redo my review and give another example where you're graphing something with even multiplicity. But we do have those in the notes, so please go back and refer to them. Now we need to draw an xy axis. I hope I squeeze some room over here for a t-table. So there's my x, there's my y. What am I going to do for my x scale? Well, look at my x-intercepts. Looks like we go out to negative 5. Now, I can't only go to negative 5 because I need to pick something between and beyond. So I'm just going to say 1, 2, 3, 4, 5, 6. That should do it. Negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Okay. Now I need a t-table. X value, Y value. So I need to plug in values that I've already found on my t-table. So in order, negative 5 is the furthest, and then some space, negative 4, and then some space, 0, and then some space, 4. Okay, I'm running out of space. 0, we got an answer of negative 720. Now we need to find some other values to plug in. So let's plot these points too. Negative 5, 0 lives right over here. Negative 4, 0 lives right next to him. 0, negative 720. I can't put that up there yet. And then 4, 0, 1, 2, 3, 4. And I didn't put the zeros out here, but they are out here. Okay. Now I need to find some other points to plug in, like say negative 6, something to the left of here. As much as we don't want to, but we have to, negative 5.5, something between these two. Something between this negative 4 and this positive 4 that we have over here. Now we've already got 0, but I don't know, maybe a negative 1 wouldn't be a bad idea also, and maybe a positive 1 or 2 over here, and then 5. So I'm going to go through the trouble of plugging all those in and see what we get. We can do the negative 6 together. So that's going to be y equals negative 6 plus 5 times negative 6 squared plus 9 times negative 6 squared minus 16. I reduce that. That's going to be negative 1 in that set of parentheses. Now negative 6 squared is 36. 36 plus 9 is 45. Okay. Negative 6 squared is 36. 36 minus 16 is 20. And then with my calculator, I can multiply negative 1 times 45 times 20. And that gives me negative 900. Again, I'm going to do a similar thing with these other values and then come back to you and tell you what they are. Okay, wow, look at all that work I got there for you. So it did take me a little bit of time to do these calculations. So the negative 900 we did together. I got a quick change on you here too. Notice I wrote down negative 5.5. Yes, I made mistakes too. The number between negative 4 and negative 5 is not negative 5.5, it's negative 4.5. I know you caught that. Thank goodness I did. When I started plugging in these values, I went, that's not right. And so I changed it, and I got 62.2. for that answer. When I plugged in negative 1, surprisingly, negative 600 pops out. You know, you could see that because of these big numbers that you're multiplying by with 16 and 9. When you plug in 0, we'd already done the negative 720. When you plug in 1, you get negative 900 because you're multiplying 6 times 10. Okay, that's already 60 times negative 15. Okay. And then when you plug in 5, you get 3,600, which is big. I don't know if I want to fool with trying to get 3,600 on my graph. We know that it's going to go up and off, you know. So let's just try to get to like close to 1,000 on the graph. Maybe we could do 200, 300, 400, 500, 1,000 on our scale. So let's say 200, 300, no, I'm not saying that right, 200, 400, 600, 800, 1,000. So there's 200, then negative 200, negative 400, negative 600, negative 800, negative 1,000. So there's negative 200. Let's see how this does. All right, so negative 6, negative 900. So way out here is negative 6, and remember that's negative 1,000, so negative 900 is right in the middle between negative 800 and negative 1,000. And then that value, negative 4.5, not negative 5.5, is 62.2. So again, just a little, not even, mine looks like it's halfway between 0 and 200, but we're just going to say, hey, that's 62.2. Negative 40, remember I don't have that one, yeah I do, I have that one plotted, I'm sorry, negative 1, negative 600, here's negative 1, again 246, there's negative 600 right there. The 0, negative 720 is the one I don't have graphed, so remember that's negative 800, so negative 720 should be about there-ish, okay. 1, negative 900, so 1, negative 900 right here. Okay, and then 40 we have plotted there, and 5, 3,600, which way up here. Just going to put it way up here. Didn't have to be on my graph at all. I connect these dots. Okay, now remember all of these multiplicities for our zeros is an odd value, which means it crosses over. And notice my graph makes it look like it crosses over too. Crosses back over, so I can pick up these points over here, cross back again, and then shoot up to make it to that 5, 3,600. So there's a rough looking graph here. Keep in mind the things that we cannot tell using this technique is what is the maximum, how high does this go. It could hit our 62 value and then scoot on up higher and then come down. Down here, it could keep going down here and probably does keep going down here and then come back up. Okay, so where your maxes and mins are, you can't tell from this technique. And again, this is why you take calculus.